Okay, you may start your presentation.
Okay. Greetings, everyone. Assalamualaikum warahmatullahi wabarakatuh. I am Nabila Shifat. Today, I'm going to present my work in a paper with the title of Identifying Soil Physical Parameter Using Downhole Seismic, where the survey took place in Chilachep, Jawa Tengah. First thing first, I will talk about the background of this research. So as human beings, we are strictly dependent on Earth's natural energy resources for our basic needs. Those energy from natural resources need to be obtained beforehand. There are many ways to do that. One of them is to use geophysical approaches. As said, to finally be able to get the energies, we have to do a preliminary exploration, which is an investigation carried out along certain broad features of a coal or mineral area, with the object of deciding whether the proposition is such as to warrant a detailed or final exploration, which is often costly. So in this research, the final output is to determine the soil properties or what kind of soil lies in around Chilachep, Jawa Tengah. In figure 1, as you can see here, I've already put an easy example for us to understand, as what I mentioned earlier about determining the soil properties. This figure illustrates information of 3 different types of soil. There's silt, sandy clay, and hard silt. This kind of information was also done with the same method. However, we're going to have a slightly different outcome as the image shown by the end of this research. Moving on to the survey area, Chilachep is located in Jawa Tengah, Indonesia, specifically in the southwestern part of Jawa Tengah, near Sakambangan Island on the Indian Ocean. As in figure 2, Chilachep is not a big town either. It's more to a seaport that was used during the Battle of Java Sea in 1942. It has roads and rail connections to the rest of Java Island. And oil refining is among the area's most important industries. According to some websites, Chilachep is the site of many industrial plants, a geothermal power plant, a cement plant for Holcim Indonesia, and one of Pertamina processing units in Indonesia. The site has the largest production capacity, producing the most diverse kinds of products among other Pertamina units. Next, I will continue to tell the purposes of this research. There are 3 purposes, and what are those? The first one is to determine the physical parameter of soils in a certain area in Chilachep, Jawa Tengah. And the second one is to correlate the Poisson's ratio value of the survey area. And the last one is finally to specify the type of soil based on its Poisson's ratio around Chilachep, Jawa Tengah. What method used in this research? Here, let me explain a little bit about the method used in this paper. Basically, the seismic method are the most commonly conducted geophysical surveys for engineering investigations. Seismic refraction provides engineers and geologists with the most basic of geologic data, along with simple procedures with common equipments. Any mechanical vibration is initiated by a source and travels to the location where the vibration is noted. These vibrations are seismic waves. There are 2 types of seismic waves, which is body waves and surface waves. Since we're using the active seismic or the downhole testing method, we're going to talk about body waves here in this figure 3. As you can see here, there is compressional or pressure or primary wave, or known as P wave here, which are the fastest traveling of all seismic waves. The particle motion of P waves is an extension and compression along the propagating direction. P waves travel through all media that supports seismic waves, such as air waves or noise in gases, including the atmosphere. As compressional waves in fluids, for example, water and air, are commonly referred to acoustic waves. And the second wave is the secondary or transfer or shear wave, or known as S waves. So S waves travel slightly slower than P waves in solids. S waves have particle motion perpendicular to the propagating direction, like the obvious movement of a rope as a displacement speeds along its length. These transfer waves can only transit material that has shear strength. S waves, therefore, do not exist in liquid and gases, as these media have no shear strength. Body waves are also related to rock elasticity properties. So this is why we didn't use the surface waves, because it only travel at some Earth surfaces. And how do the downhole seismic testing work? The downhole method is a seismic geophysical method which output is in the form of reading or interpreting the structure of the subsurface layers of the Earth in the form of soil and rock material properties by using direct seismic waves. In this case, are the P waves and S wave as depth function. Based on the relationship between velocity and depth, the layer structure and the type of material that make up each layer will be identified. And this testing measures vertical changes in seismic velocity by placing a source at the top of a borehole. This is the borehole. And measuring travel times at multiple intervals in the borehole, usually with a 3-component geophone. As you can see in the schematic in figure 4, here is the upper component 3-component geophone, and this is the lower 3-component geophone that are placed a meter apart from each other. So the receiver is in the form of each geophone, and the wave source is from the shot or blasting points here. This method uses direct wave propagation, where the geophones receive and detect the first wave that reaches the geophone without seeing other wave refraction. Now moving on to the process of the data processing here. First, we obtain the VP or the pseudo velocity in the form of a pressure or compressional wave, and the VS or the shear velocity in the form of the shear wave. Next, we correlate the Poisson's ratio value. We will match up the VP, the pseudo velocity and shear velocity to the value to the Poisson's ratio value, and then finally we can determine the physical properties of the soil based on the value that we matched up earlier. And what are the limitations and benefits of this survey? So the data were collected using Sestronic RAS-24, and this measurement is carried out by taking the data gradually for each depth of 1 meter from the deepest. And this data collection was carried out to a depth of 18 meters. So there's going to be 18 data points. And unlike the other testing method or cross-fall, the wave source stays on the surface. This means that the wave paths are largely redundant from one geophone to the next. And we are looking more at the difference in travel time with depth and at the slope of the travel time curve rather than the absolute travel time for each shot, much like seismic reflection. And what is the benefit of the survey? So this is more to a preliminary exploration to identify the type of soil in a certain area in Chilachep, Jawa Tengah. So the following result can proceed to begin the exploration of Earth's natural resources. How do we process the data collected? Here in figure 5, we can see that the data were processed through a PC software called Window. First, we converted the data from DAT formatting to SU formatting, where here is the raw data of P waves and S waves alongside with the noises. And after we converted the file, we're going to do the data picking of the first arrival propagating waves of each wave of each P waves and S waves using the same softwares. We do this to determine the parameter of travel time and velocity, density, Poisson's ratio value, shear, Young, and bulk modulus from each layer that were represented into graphs. So here is these are the graphs. The first one is in figure 7a. We can see that S waves here in red spent a longer time to travel through the borehole travel and the P waves travels faster than the S waves in blue. And in figure 7b, we can see that the relationship of pseudo velocity and shear velocity towards the depth of soil, which basically supports the statement in figure 7a. And in figure 8a, we clearly can see any curves on the graph. That was because of the value of the Young modulus is very small, thus the soil properties dominated by a very soft clay. And here in figure 8b, we can see there's some fluctuation in the trends that represent different meanings for every depth, although these values are still considered very small, around 1 to 2.2. These very small values shows that the soil in the survey area is less able to withstand vibrations such as earthquakes. And here in figure 9, as seen here, the bulk modulus has similar fluctuating curves with small values as the shear modulus. Hence, it indicates that the soil in Chilachep has non-rigid properties, and it is likely that the soil layer is wet. And finally, the relationship of Poisson's ratio value towards the depth that will determine the soil properties. As seen in figure 9b, each layer has different values as well. For the depth of 1 to 8 meters here, 11 to 12 meters, and 15 to 18 meters, the range of the value is around 0.37 to 0.6, which tells that those layers are saturated clay. While in 9 meters and 14 meters depth, the value is above 1, which indicates that the soil layer is sand. And lastly, for the depth of 10 to 13 meters, 10 and 13 meters.
I'm sorry to interrupt you. You have 1 minute to conclude.
Okay. Okay, so to conclude everything, I would like to point out the important information from the result. So the parameters that have been determined are the shear, Young, and bulk modulus. Those parameters vary in small values that tell the strength, types, and characteristics of soil in Chilachep. And the Poisson ratio value that have been obtained and match up has identified the soil properties in area which is dominated by saturated clay, followed by sand and unsaturated clay. So that brings us to the end of my presentation. Thank you.
Okay, thank you, Nabila. Questions from the audience? Yes, Ayunda.
Hello, my name is Ayunda, and I have a question for you. So for the testing method, why you use body wave instead of surface wave?
Okay, the reason why we use the body waves in all seismic method is because surface waves doesn't really I'm sorry. Let me search that quickly. Doesn't really so the surface waves doesn't really travel to the Earth surface. It only travel to some Earth surfaces. That's why we use the body surface.
Is that answering your question, Ayunda?
Yeah, thank you, Nab.
Okay.
Okay, another quick question from the audience. Okay, in this study, are you doing it by yourself or is it from a paper?
I'm sorry, sir.
Is the downhole measurement is done by yourself or is it coming out from a certain paper that you cite?
It is actually my Kermantau, sir.
Oh, okay.
Last semester, but the data it was from the senior. from
Oh,
Kati.
okay. So from okay, so from your cutting. Okay, Jovan, have question for Nabila?
Yes, Nabila, I want to ask you about what is Poisson ratio and why the soil properties depend on its value.
So the Poisson's ratio itself is an elastic constant that represents the physical properties of the rock. So if after we get the values, we can correlate, we can match up the values to the description of what kind of soil lies around the survey area.
Okay, thank you.
Okay, I hope that's answering Jovan's question. Because for let us applause Nabila for the first presenter of today's sessions, so that we can move on. Okay, thank you, Nabila.
Thank you.
So that we can move on to Nermina, which is going to talk about sentiment analysis of Twitter due to COVID-19 pandemic.
Yes, sir. Is it my voice clear?
Yes. Okay, you may start anytime you're ready.
Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. Good day, Mr. Hari, and everyone here. Thank you for the time. Let me introduce myself. My name is Nermina. I'm from PC Covered and Complex System Research Division, Faculty of Mathematics and Natural Science, Institut Teknologi Bandung. Today, I'd like to present my research study about sentiment analysis of online learning on Twitter during the COVID-19 pandemic using the naive Bayes method. As a background, we know that the outbreak of COVID-19 in China was reported due to the rapid spread of the virus in the world. On March 2020, WHO declared the COVID-19 virus is a global pandemic. The rapid spread of the virus to physical contact forced all countries to implement social distancing and physical distancing to reduce interaction. As a result of this policy, many sectors were paralyzed, one of which is education sector. This strategy prohibits face-to-face learning and replaces it with online learning. However, online learning became controversial because it needed adaptation. Differences in infrastructure, connection quality, device use, and the high cost of internet quota are the main obstacle. Next, this study to analyze public opinions on online learning during the COVID-19 pandemic in Indonesia from September 20 to October 31st, 2021. This research study used keywords online learning on Indonesian tweets, which were pulled from Twitter and processed by naive Bayes algorithm. We're gonna move on into text mining. What is text mining? Text mining or text analytics is the analysis of unstructured data contained in natural language text using various methods, tools, and techniques. This is figure 5, show the text mining process. Start with determining the target data and then crawling the data. After the data is obtained, it enters pre-processing data, which include cleaning, stemming, and tokenizing. The data will be cleaner after the pre-processing process and can be called pre-processed data. And then transform into transform data, and text mining will merge into data mining. Data mining are used in structured database. And now we can see the patterns and modeling process can be executed. And in the end, we can get useful information from text mining process. Next, After we talk about text mining, now what is sentiment analysis? Sentiment analysis is the process of determining sentiment and classifying the polarity of text in a document or sentence. So it can be classified as a negative, positive, or neutral. The positive class contains praise, suggestion, or positive emotions such as happy or pleasure. And the negative sentiment contains disappointment, criticism, and negative emotions such as anger and upset. Okay. Next, we're gonna move on into naive Bayes classifier. The naive Bayes method is a classification method in text mining and sentiment analysis. This method is potentially good in classification in terms of precision and data computation. The main feature of naive Bayes classification is to obtain a strong hypothesis of each condition or event. Calculation of probability categories in naive Bayes use the Bayes algorithm. Approach using this equation. Equation 1 shows Pyx equal to Py times Pxy per Px, where y is specific class, x is data on an unknown class, Pyx is hypothetical probability based on condition, Py is probability of even y, Pxy is conditional probability of x given y, and Px is probability of even x. Next, from equation 1, we can develop into equation 2, where equation 2 is same with equation 3. That we know that P y x1 until xn is a posterior probability, Py is prior probability, Px until Pxn is evidence. Naive Bayes assume that each attribute is independent. Next is classification model evaluation. To measure the performance of the classification model, we can use by comparing the actual with the predict value. The confusion matrix is a performance measurement for machine learning classification problems where the output can be 2 or more classes. 4 terms of the result of the classification process in the confusion matrix. There are true positive, false negative, false positive, and true negative. Next, the first step in this research method is collect data in Python. To be able to connect to Twitter, it is necessary to request an access token code obtained from Twitter API. By requesting the code, we can crawling the data. After crawling the data, the next step is labeling the data. And the next is after crawling, labeling, we enter into pre-processing data that include cleaning, scaffolding, stop for removal, tokenizing, and stemming. The next step is testing the model. After modeling, the accuracy and precision value will be obtained. From that value, the result of the analysis and research are complete. Okay, we're gonna move on into the result. Table 2 shows crawling data result. Where tweets are still diverse, indicated by mention, hashtag, URL links, capital letter, punctuation, and many more. And in table 3, after we have data, we must labeling the data. The labeling has 3 categories. There are negative, positive, and neutral, like shown in table 3. The next step is scaffolding process. After modeling, after the labeling, don't forget to change the capital letter into lowercase. In this step, all the capital letters change into the lowercase that's shown in table 4. Okay, next step is tokenizing and stemming process. Tokenizing is a change a sentence into word, and stemming is change a word into basic word. From show that table 5, the one sentence change into 8 word, and the word is a basic word. And in this stage, don't forget to remove words that have no meaning, like I am, about. So the word just meaning like parents complain is different than other words. Okay, nah, the result. After modeling with naive Bayes method, only 34% have a positive sentiment, 57% dominate in negative sentiment, and remaining 9% in neutral. And in a figure in the left side, there are number of positive, negative, and neutral. The result of positive predictive data, which are included in a positive category, are 241, with 6 being false positive and 9 being neutral. And the negative category is 409, being negative category, with 8 is false negative, and the remaining 12 being neutral. And the neutral category is 56, being neutral category, with 6 and 5 being false positive or negative. From confusion matrix, we can conclude that the accuracy value of this research study is 30.8%, and precision value is 94.1%, and the recall value is 94.5%. And the last slide is a conclusion. From this research study, we can conclude 2 conclusions. And the first is the result of the analysis of public opinion on online learning during COVID-19 pandemic in Indonesia from September 20 to October 31st, 2021 show that 34 are positive sentiment, 57 negative are negative sentiment, and 99% are neutral. Negative perception are generated due to public dissatisfaction with online learning. Based on this result, it is known that online learning has not been maximally implemented in Indonesia during pandemic, which can be seen from the high level of public disappointment. Besides that, students also feel bored and tired because they have been studying online for almost 2 years. And the second conclusion is, based on the evaluation result of naive-based method for sentiment analysis regarding online learning, the value of accuracy is 93.8%, precision is 94.1%, and recall is 94.5%. It can be seen that each value of accuracy, precision, and recall has a value above 90%, which means the naive-based algorithm can make the decision-making process easier and on target. Okay, this is all from me. Thank you so much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Okay, questions from the audience. Fadila.
Okay, thank you, Narmina, for your presentation. I have 2 questions for you that are, first, is there any other methods to do sentiment analysis instead of using naive Bayes method, and what are the advantage of using this naive Bayes method? And the second one is over the entire process, when we do processing data, which stage is the most important and needs more attention? Thank you.
Okay. Thank you, Rizal, for the question. For the first question is, Is there any way to do sentiment analysis beside a naive-based algorithm? Gitu? There are another way to analyze sentiment beside naive bias is to use I know support vector machine or SVM and maximum entropy classification and k-near snakebore. Yeah, three of that. And what is the advantage of naive bias? Is are of use? Okay, the first advantage is fast processing time, easy to implement with a fairly simple structure, and naive bias result has a high level of effectiveness. Yeah, okay. There is for the question 1, and for the second question is of the entire processing method, what stage, which state most important? In naive-based method, the process that requires more important is at data preprocessing. Why? Because at this stage, it is very influential on the accuracy value that will be obtained in the end. The cleaner the data generated from data preprocessing, the greater the accuracy, precision, and recall. So it is necessary to pay attention to what aspect must to be done so that the data becomes cleaner. In this research, such as eliminating URLs, hashtag, mention, retweets, and punctuation. Yeah, that's my answer.
Okay, I hope that's answering results questions. But since we are running out of time, thank you for your presentation. Regarding the technicalities and also the details about your, so is this, so I guess this is part of your final project. Is it part of your final project, or is it a thing that you just select for the class?
I just select for this class.
Oh, okay. So it's not a particular work on a final project, but it is true that the topic itself is interesting because I'm wondering if we increase the size of the data, of the collected data, and also when you train the data longer, would the accuracy and the precision will differ from the one that we already have here, because in this study the number is quite high, above 90%. So if we increase the limit of the data set, will change dramatically. Okay, again, thank you, Narmina, for your presentation. So now we could move on to the third presenter. It's going to be Anita and talking about radiation dose for treatment planning system.
Yes, sir. Right. Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Sanggita Nandakiri. Here I want to talk about the scientific paper is about estimate 3D radiation dose for treatment planning system TPS Lineage, use percentage depth dose or PDD data and profile dose. Cancer is one word which is not a strength for us. Yes, cancer is a disease characterized by the growth of cells that spread abnormally and uncontrollably. This often causes death for the sufferer. And for treat this cancer cell, radiotherapy is the answer. Radiotherapy is the most effective cytotoxic therapy available for the treatment of localized solid cancer and must be carried out properly and also directed through the TPS or treatment planning system, where later The TPS will evaluate the distribution of the right radiation dose for target irradiation. Estimation of the radiation dose distribution was carried out, which was presented using an isodose curve, which would involve PDD or percentage depth dose data and dose profiles. For last research, all studies have only produced a 2D isodose curve. This can cause the radiation dose not to be inaccurate. In this research, radiation dose estimation is performed which show the distribution of surface radiation dose for all depth variation on one curve, resulting in a 3D radiation dose estimate. So, with this paper, we hope the radiation dose to the target can be carried out more accurately, especially on photons. First, let's talk about treatment planning system or TPS. Here's therapy based on the principle of radiotherapy must be well planned and targeted. And the planning is done by using a radiation dose called the treatment planning system or TPS. Here's figure number 3 show irradiation axis schematic. There are cross line as x-axis, inline as y-axis, and the depth as x as z-axis. Cross line and inline is field area in profile dose curve, whereas depth value from PDD curve. And then TPS will produce beam set and radiation dose distribution on the irradiation target. Next, about percentage depth dose or PDD and dose profile. The dose profiles show the radiation dose distribution along the main axis or face or surface on a horizontal or vertical axis perpendicular to the direction of the incident light. And PDD show the distribution of radiation dose in percent along the principal axis in the direction of incident light. For measurement, surface radiation dose distribution can be measured by the first question, where dxiyi is the radiation dose distribution of the surface in the xy area. Dxi is the percentage value of radiation dose profile, dose cross line at point I, and dyi is the percentage value of radiation dose profile dose inline at point I. Dxcax is the percentage value of radiation dose profile dose cross line at the central point of irradiation or central axis. And dycax is the percentage value of radiation dose profile inline dose on the central axis. Furthermore, the distribution of the radiation dose to the surface is multiplied by the percentage value of the radiation dose to the PDD according to the depth variation used. Using equation number 2 to become an estimate of 2D radiation dose at each depth, where the dxiyiz is the distribution of radiation dose to the surface at certain depth, and PDDz is the percentage of radiation dose of certain depth. All 2D radiation dose estimates at various depths are integrated to their depth on one curve to form a photon 3D radiation dose estimate. Next, for the method. In this research, the linear lineage used is type Clinic CX at the radiotherapy installation of the Andalas University Hospital. And for percentage depth dose and dose profile data using chamber reference ionization detector and blue phantom as substitute for the human body. There are two important pieces of data in this research. With figure 5 schematic of data radiation dose, this research was carried out using two methods. The first method was collecting PDD data and dose profile using a LINEC, and the second is processing PDD data and dose profile is used to estimate 3D radiation dose using MATLAB. For next, the data processing. First, PDD curve and dose profile have been converted in numbers, and then set in Microsoft Excel and do interpolation using MATLAB with create a new interval of 0.1 millimeter for each data. And then the estimate value of 2D radiation dose is obtained. So the integration is carried out according to the depth, and then the estimated value of 3D radiation dose is obtained. Next, the result of this research. Percentage depth dose or PDD. Show with a figure number 7. There is PDD curve formed at 6 MV and 10 MV photons energy. Have a different percentage of radiation dose. This is because the percentage value of radiation dose is influenced by the amount percentage of radiation dose at each depth point. And this higher energy will result percentage of radiation dose will be higher. And this lower energy cause a smaller percentage of radiation dose at each depth point. This can be seen from the compound effect. If the energy used is higher, there will be more opportunities for ionization, thus causing the percentage of radiation dose to also increase. The PDD curve show that the percentage increase in radiation dose occurs from the zero depth point or surface to the point of maximum radiation dose depth. Percentage the maximum radiation dose produced indicate that the percentage of radiation dose generated at the maximum depth reach a value doses to 100% or exactly at 100%. The area where the percentage increase in the radiation dose occurs is known as build up. There is cross-line dose profile curve in 6 MV and 10 MV photons beam. From the data show if the relative dose value for the cross-line dose profile for 10 MV photon is larger than average relative dose profile for 6 MV protons energy at each point in the field. And then the variation of depth affect the relative radiation dose received by the target irradiation. When the depth of the irradiation target is lower, the width of the radiation dose distribution relative to the resulting field area becomes smaller. Same condition with the inline dose profile curve. That the relative value for the crossline, the inline dose profile, and for 10 MV more is greater or is larger than the average relative dose profile for 6 MV protons. And the variation of depth affect the relative radiation dose received by the target irradiation. It causes the increasing depth cause of scatter radiation to be larger, and the lower depth cause more or less scatter radiation. Next, about estimate 3D radiation dose. The color in the image of the estimated radiation dose represent the percentage of radiation dose at each surface point with respect to depth variation. variable represented on the x-axis are cross-line, on y-axis are inline, on z-axis the depth of the phantom surface on irradiation. And the radiation dose estimation pattern generated using MATLAB in this study. And the pattern already resembles with the radiation dose estimation pattern as standard TPS from Andalas University Hospital. Next, in conclusion from this research is the pattern already resemble with the radiation dose estimation pattern at standard TPS from Andalas University Hospital. And from the figure, we can take a conclusion that the radiation dose distribution will be wider and the radiation dose value will decrease as the irradiation target depth increase. And the use of higher energy cause the value of the radiation dose distribution to increase at the same depth. That's all my presentation for today. If anyone has question, I would be happy to open up the discussion. Thank you for your attention.
Okay, thank you, Anggita. Questions from the audience? Okay, Rivka.
Okay, thank you. My question is, can you go to the slide 11? Okay. In this figure, the curve of PDD is decreased. There is a decrease in the curve after reaching the maximum value of radiation dust depth. So what causes the decrease from the curve? Thank you.
Okay, thank you for your question. On slide number 7, we have a PDD curve. There are PDD curve at 6 MV and 10 MV energies. They show us about the relationship between percentage depth dose and depth of phantom. And look at this point. This is point of the maximum radiation dose depth because the percentage of radiation dose generated at the maximum depth reach a value close to 100% or exactly or at 100. And the area known as build up area. The build up area may occur due to high energy photons being fired towards the electron of the medium atoms. So the atoms ionize due to presence of atomic electrons that absorbs energy higher than their binding energy. When the atomic electron that come out due to the hard collision have a high speed, then the atomic electron also contribute to an increase the radiation dose in the build area. After passing through the build area, the percentage of radiation dose that occurs is decreasing exponentially. That's my answer.
Okay, any other question from the audience? Okay, Hauda.
Okay, Ray, I want to ask you, on slide number 12 and 13, you show two figure of gas profile, but I have not idea how can that figure is so similar, the table in the image. Can you explain more about the figure? Thank you.
Okay, thank you for the question. So yeah, basically on slide number 12 and 13 is just show two figure or two curve with different axes. There's inline and the cross-line curve. And on this research, we use three axes. There's inline, cross-line, and depth, which is inline for y-axis, x-axis is inline, and the depth for z-axis. So the figure shows us the relationship between relative dose on percent and voltage on millimeter with depth variation. For inline and cross-line curves, both show that width of voltage will become larger when the depth of the target is higher. Why use x-axis and y-axis? Because here, this research use an isodose curve. So to show the distribution of radiation dose. Then crossline and inline are voltage from dose profile. So that's why both two curves have a similarity.
Okay, thank
Okay,
you,
thank you.
Rifkah and Hauda, for their questions. And also thank you for Anggita for giving us
Thank you, sir.
concise explanation on the cancer treatment. Okay, and therefore we're going to move on to our fourth presenter, which is Balia Alfata, talking about empty inversion using artificial neural network.
Thank you, sir. Can you hear my voice?
Yeah, we can hear your voice. Yes, yes, we can hear.
Okay. Good afternoon, everyone. My name is Balia Alfata. I am from Physics Study Program in Physics of Earth and Complex System Research Division. Today, I'm going to talk about my research about 1D magnetotelluric inversion using artificial neural network method. So the outline of our presentation today, it would be, first is the background, and second is the artificial intelligence. Next, we're going to talk about magnetotelluric inversion, and we're going to talk about artificial neural network and the method that I use for this research. Background of my research. When we are searching on about the technology and the future, we always come up upon one topic that is always mentioned, that is artificial intelligence. Like, what is artificial intelligence? Why is it trending? What is the benefit of using it? So artificial intelligence is similar like a machine or a robot, but the difference is that we don't need to program them to how they can solve the problems, because they can solve it by themselves, which is even better. So that's why it's trending. And in a society where most people are really busy, we could really use a tool like artificial intelligence support tool that can solve more problems with more efficiency. And artificial neural network as a tool of artificial intelligence can model physical phenomena without mathematical representations. So for people not from the scientific environment, it's really easy to use, and it's easy to access because we can do it on a simple programming language on Python, for example. And I'm going to use this artificial neural network on something that rarely use the artificial intelligence, which is the magnetotelluric inversion. This is also from my research division, which is Physics of Earth and Complex System. As we are talking about artificial intelligence, there are wide use of it, and also in our daily life, which is like smart assistant, like Siri, Alexa, and OK Google, if we are using it. And then a social media recommendation like Netflix, self-driving cars, email spam filters, and one it's on our daily life, like, but not everything. Like if we look at a toothpick, of course it doesn't have artificial intelligence, but any gadget like our handphone, our TV, we open up the TV, look at Netflix, and the first homepage, that is the recommendation, it is from artificial intelligence. So the use are very good, very many of them. And for magnetotelluric inversion, for those who doesn't know, the simple explanation to it are the utilization of penetration of electromagnetic waves below the Earth's surface. We shut it down to the Earth's surface to determine the impedance of a material, where material here is the Earth's layers from underground, which is maybe rocks, maybe soil, maybe water, maybe oil, and it has many use because Earth is a part of us, part of the humanity, and we need to make use of its resources as maximum as possible. And here's the example of magnetotelluric inversion. This is an example of a 2D magnetotelluric inversion, where we have the horizontal position, and you can see here is the place where we shot the frequency, the electromagnetic waves. And from here we go down, and when the different kind of resistivity, different kind of layer of Earth, it will reflect another frequency where we will catch it. And that from that frequency, that reflected frequency, we will determine the impedance of the material under the Earth. And for artificial neural network, it's a really cool thing. It is inspired by our brain, which has many neuron systems, and this is the same thing inspired by it, where we have 3 inputs. Here is an example of artificial neural network where we have 3 inputs and 1 output. So and there are 2 hidden layers here with 4 neurons, each with 4 neurons. And these lines, they is the connectors, where each line will have to be weighted. Like this, we have input 1, input 2, input 3. Input 1 will be converted into this by a certain kind of percent. Input 2 to this, and input 3 to this first hidden layer by a certain kind of percent. But we don't need to think about how many percent do we put it here, how many percent do we put it on the hidden layer 2, because the artificial neural network will build a function or a model where it is consisting of the weighted neurons, where weighted connectors, which this one, and they will decide how many percent of input layer 1 into input hidden layer 1, and we just need to determine the optimize the learning rate and how many times do we need to train it. So basically, artificial neural network need to have a lot of data for it to work efficiently. So that's about artificial neural network. And the forward modeling method, here is the equation, which is a derivation from Maxwell equation, where we have Z here as the impedance, which consists of the Z from the underneath layer, and the T, the SZ, where T as Z is just variables, which consists of these 6 individual variables, which is load density, electric conductivity, electric permittivity, magnet permeability, angular frequency, and the depth of each layers. And from the forward modeling method, we're gonna put the input is the row, the H, which is depth, and F is the frequency, where rho is load density. And we're going to have many frequencies shot and determine the impedance of the M layer. M is the undermost layer, which is we're going to determine, and we're going to work our way up. M minus 1, for example, we have 5 layers. We're going to start from the underneath layers, the undermost layers, and which is 5, M equals 5. And we're going to minus that minus 1 until it is the uppermost layer. And then we're going to determine the rho and the phase from the impedance. From each layer, we're going to shoot another frequency, which is n number of frequency from 1 until n number, which n number is whatever we want, how many frequencies to be shot. And from there, we're going to determine the rho and phase function. As here this is my programming for formula translation language, or Fortran, where W is a complex number here, and the derivatives, which consists of T, S, T, and Z, we're going to make it a complex variable. And for the frequency, we have like 18 frequencies here, and we're going to analyze 20 or lower layers. So we're having the W and the Z as an array of 20, maximum of 20 values in it. And the rest is just converting the equation from the previous slides into the formula translation programming language. As for the AN method, here is an example where we store our data into a Excel format, which is data.csv, and for the first until the 8th column, we're going to put the input, and for the 9th column, we're going to put the output, which is Y, and the input, which is X. And here's the AN that I'm going to use, where we have 8 inputs here, and the first hidden layer will have 12 different neurons, and the next hidden layer will have 8 neurons, and the output layer will have 1 neurons, where I'm going to use a 20 epochs and a batch size of 10. The result of this research is this different data, where we have the blocky method and the Occam method, where when it's going to the right, it means that the layer have less independence, and if it's going to the left, it have more impedance on the layer of the Earth. And this is the height, the depth of the Earth. And I think that's about it about my research on 1D magnetic inversion in an artificial neural network. If you have any questions, I open the floor for it.
Okay, thank you. And just after you've done with your explanation, Arfian has raised his hand. Okay, Arfian, question for, oh yeah.
Yes, sir. Is my voice clear?
Yes.
Okay, so I just want to ask Bali about, so after all, why did you choose 1D magnetotelluric inversion? Why not the other? Or can you explain to me? Thank you.
Okay, thank you, Apian, for the question. Great question, by the way. For the 1D magnetotelluric inversion, why did I choose it? I'm going to look for the magnetotelluric inversion. Why I choose magnetotelluric inversion first? Because it is from my research division, which is physics of Earth and complex system research divisions. And I choose the one-dimensional because artificial neural network is an alternative method because we already have the more popular method like Occam and Blocky. And because it is an alternative method, I'm just testing it. So the more simpler way of testing it is testing it on 1D inversion, where we just shot to the ground and we just determine one layer, I mean one direction to the ground. We don't have to determine the horizontal position, we just determine the vertical position. So it's more simpler. If I success in doing the using the artificial neural network, possibly it can be used on higher magnetotelluric inversion like 3D magnetotelluric inversion. Thank you.
Okay, thank you, Balia.
Okay, another question from the audience. Okay, so Baoya, the input of your artificial neural network algorithm, is it an image or is it a time series?
It's a time series, sir, not an image. It's a time series, and
this from yes, continue.
Yeah, it's a time series from the phase and the frequency and the depth of each layer. I'm going to, the output is also not like a time series. Like this, each point will have, the output is the each point in the depth of the layer underneath.
Okay, but the input itself is a time series that a normal empty equipments will produce, right? So how many inputs? So how many measurement points that you look for a good prediction using neural network?
Oh, actually, the data is already from my lecturer, sir.
And how many inputs? And how many inputs are there? How many measurement points?
There are 8 measurement points,
okay.
like frequency and the rho.
Okay. Okay. So, have you done a parametric test? Have you tried if you are using 8 or 4 measurement points? Will the neural network result will be the same or will be different? Have you tested?
I haven't tested to that.
Okay.
Point, sir.
Okay, because machine learning, artificial intelligence, and also neural network, it is assumed that the number of inputs that is implemented into that algorithm, some say it will determine the outputs, the result of the interpretation. But if there are no any significant differences, it means that we could just plug in less measurement points to get because it doesn't mean that it doesn't mean that more data will produce more accurate result, but it needs to be tested before we can conclude to that statement. Okay, thank you, Balia. With that, we are moving on to the 5th presenter, which is Muhammad Ridho Nurul Isan, talking about geothermal potential using ERT in Krafla, Iceland.
Yes, sir. Can you hear my voice?
Yes.
So there's a problem with my Zoom, unfortunately.
Okay, do you need to restart your machine, before you're starting your presentation?
Oh,
Because usually this is happen when there's some kind of a trouble that needs to be restarted.
oh yes, yes.
Okay.
I need to restart my laptop.
Okay, okay. Is Nabila? Okay, we have the second Nabila. Is Nabila Safli Ramadhani in the classroom?
Yes, sir.
Okay, could you replace Rido's presentation before he's starting his own? Could you start now if you are
Yes,
able
sir.
to do it? Okay. Okay, so the fifth presenter is going to be Nabila Safri Ramadhani, who is going to talk about physical distancing on the COVID-19 spread using agent-based modeling. Okay, the time is yours.
Okay. Good morning. Good afternoon, Mr. Hari and everyone. My name is Nabila Safli, and today I would like to present my research about the effect of physical distancing on the COVID-19 spread using agent-based modeling. So coronavirus disease, or COVID-19, according to the World Health Organization, is an infectious disease caused by the SARS-CoV-2 virus. The coronavirus was declared as a global pandemic in 2019 and has become a big problem until today. COVID-19 spreads when an infected person breathes out droplets and very small particles that contain the virus from their eyes, noses, or mouth. In some cases, they may contaminate surfaces that they touch. According to COVID-19.go.id, Indonesia has reached more than 4 million cases and more than 140,000 people have died because of COVID-19 until last September. The implementation of new policies such as lockdown and social distancing was carried out by many countries, including Indonesia, to reduce the spread rate of COVID-19. The practice of social distancing means staying home and away from others as much as possible to help prevent spread of COVID-19. The practice of social distancing encourages the use of things such as online video and phone communication instead of in-person contact. As communities reopen and people are more often in public, the term physical distancing is being used to reinforce the need to stay at least 6 feet from others, as well as wearing face masks. Historically, social distancing was also used interchangeably to indicate physical distancing. However, social distancing is a strategy distinct from physical distancing behavior. Basically, this research aims to understand the spread of COVID-19 disease and also to prove whether the physical distancing will affect the spread of COVID-19 or not. And I hope that the result can help the government to improve their policies to reduce the spread of COVID-19 in the future. So the behavior of the COVID-19 spreading agents can be simulated using an agent-based model. Agent-based model, or ABM, are computer models that attempt to capture the behavior of individuals within an environment. Agent-based model can be used to simulate the interaction in the population so we can analyze the small changes in behavior. In this research, the simulation is derived from the formulation statements and data retrieval that will be processed by NetLogo software. As you can see on the screen, some of the simulation have been widely used in various fields and applications from social science, politics, and economics, including simulation of evacuation models, traffic, flow management customer, stock market, and so on. ABM is defined as a technique for the simulation modeling where a set of agents is modeled in a system and also the relationship between them. ABM uses a bottom-up approach to see the interaction of individual behavior that can affect system behavior with computer-based simulation. The main element in ABM modeling is an agent, and each agent acts and behaves with the rules that are created in its environment. According to Makal and North in 2010, there are 3 elements in ABM. 1, a set of agents, including their attributes and behavior. 2, a set of relationships and interaction method, including typology for the relationship and defines the interaction of the agents. And last, the agent's environment. Agents interact with other agents and also their environment. In 2010, Valdez made an ABM simulation to see the behavior of the COVID-19 spread by adjusting the physical distancing parameters and the hospital capacity that provided. In accordance with the characteristic of agent-based modeling, agents have various characteristics during simulation. Some agents have the same characteristic and some are different. These characteristics will be set through several parameters directly. Some characteristics that will be set in the simulation are morbidity, including probability of infection, incubation time, severity, mortality rate, and length of illness. Also, there are levels of physical distancing, number of agents in an area, and hospital capacity. Agents represent people in an area and are divided into 6 conditions, including healthy, infected, ill, severe, immune, and dead. In this model, some assumption and scenario will be applied. Here, assumptions are set for the simulation. For morbidity, assumptions are taken from the fact about the COVID-19 virus. The percentage of infection probability will be set at 5%. Incubation time of COVID-19 based on existing data is 5 until 6 days. So here will be set at 5 days. Severity rate at 20%. Death rate at 19% lead to a total death rate at 3.8% and COVID-19 illness average duration at 14 days. Also, the simulation will be set by 20 for hospital capacity and represented by 200 agents. And there will be 3 scenarios in the simulation with different levels of physical distancing adopted from several conditions that happen in Indonesia, including PSBB, new normal, and PPKM. The difference level of physical distancing in each scenario will be set by PSBB when Indonesia have really restricted activities, including stopping work and school activities, restrictions on public places and transportation, also restriction on social cultural activities that will be set at 0.9 social distance. New normal, when Indonesia tried to adapt the COVID-19 condition and public activities are functioning again, that will be set at 0.2 social distance. And last, PPKM, when Indonesia limits offices and school by implementing work from home and some of the public places can open with strict health protocol, that will be set at 0.5 social distance. The other parameter values in the simulation are considered to be constant. The result of the simulations are the number of affected agents, the number of dead agents, and the duration of the pandemic. Simulations are repeated to see the result of the variations. In general, the flow of the COVID-19 spread simulation can be explained as, first, initial condition of agents are healthy. And then there is one infected agent at the beginning of the simulation where the infected agents can still go around. Depending on the chance of infections, other healthy agents within the infectious radius will be infected randomly. If agents are infected more than the incubation period, agents will become immune or sick, where the sick agent will stop going around. And sick agents have a random chance of being severe or can recover and have immunity. If there are sick agents while the hospital capacity is full, the agents may die. However, if the hospital capacity is still available, the agent will be treated and their condition depends on the duration of the illness. And randomized severe agents' chance of dying depending on the mortality rate specified. In addition, the sick agents can recover and have immunity. And last, an immune agent only lasts for a specific immune time. And for this result, it can be seen that here is a graph of the percentage of agents who are healthy, infected, ill, severe, immune, and dead. From the PSBB scenario, which in fact succeeded in reducing the number of COVID-19 in Indonesia by 2020, where in the simulation was set on a scale of 0.9 social distance. Although the pandemic cycle lasted for a long time, which is 182 days, based on the result, the graph show that the number of infected agents was very small and the number of dead agents could be said to be almost non-existent. The availability of hospital capacity has also decreased several times when there are sick agents, but it doesn't run out. This condition can prove that PSBB and strict social distancing are very effective in suppressing the spread of COVID-19 in Indonesia. And then the result of the simulation for the new normal condition show very different result from the PSBB condition. The social distance that's set at a very low scale, which is 0.2 for new normal condition, where Indonesia started to adapt the COVID-19 condition and public facilities are functioning again, made people careless, and eventually the number of COVID-19 in early 2021 significantly increased. The simulation proves that there is a condition when the number of sick agents is very high and there is no availability for the hospital capacity, which means the hospital are full of COVID-19 patients. Although the cycle of the pandemic is very fast, the dead and affected agents on new normal are more than the dead and affected agents from other conditions. And last, with the 0.5 social distance scale, where PPKM is a new policy to solve the COVID-19 spread after new normal in Indonesia, the result of the simulations show that in this condition, there is a spike cycle when many agents are sick and the hospital capacity is full, even though the period in this condition is longer than the new normal condition. The longer pandemic cycle in this condition makes for recovery agents also less dead agents, and it was proven from the current condition in Indonesia that cases were decreased during PPKM. However, the public remains to be always beware because experts, including Ikatan Dokter Indonesia, predict that the third wave of COVID-19 will be in the next of December 2021. From this, we need to emphasize that as long as the COVID-19 case is not over, health protocols, including the implementation of social distancing, must be strictly enforced to suppress the spread of COVID-19. For the conclusion, simulation that use three scenarios adapted from several conditions that happen in Indonesia, including PSBB, new normal, and PPKM, shows that social distancing has an effect on the percentage of dead agents and affected agents, and also the duration of the pandemic. The most dead and affected agents happen when the scale of social distancing is low, or in this case, is from a new normal condition. And the longest duration of the pandemic occurs when the scale of social distancing is high. It can happen because, as evidence after a long time, by implementing strict social distancing, the COVID-19 virus will not spread. The result of the simulation become empirical evidence by the government to make better policies to reduce the spread of COVID-19. Other scenarios and additional parameters for the simulation are necessary for the next research to understand the phenomenon of COVID-19 pandemic that occurs in various regions in Indonesia. So maybe that's all for today's presentation. Thank you. And if you have any question, please ask at the moment.
Thank you, Nala. Question for Nabila from the audience. We have Dirli and Muhammad Raka. Okay, I will let Dirli first and then Raka.
Okay. Thank you, Nabila, for the explanation. So I have a question for you. Can this model be used to simulate other virus, and how's the model become like this? Thank you.
Okay, actually, ABM can simulate the spread of virus proven from the existing models like for HIV virus or malaria virus, but for COVID-19 model, which has its own characteristic, it cannot be used to simulate the other virus. And for the model, it is made from NetLogo software with a programming language base. We can get the code example models that can be found in the models library in NetLogo. And from that code, because NetLogo is made up from agents, so we can use agents in the form of turtles, pages, links, or the observers. So after that, we can set various parameters such as what we want and what we need. Is it answered?
Okay, I got it. Thank you, Nav.
Thank you.
Okay. Now is Muhammad Raka Fauzan to ask.
Okay, Thank you, Sophie, for the explanation. So I want to ask a question. Is ABM the best model to explain COVID-19 spread?
Okay, maybe many models have been successful in explaining COVID-19 spread, like the epidemiologic model used by policymakers, clinicians, and public health practitioners. But ABM is also definitely suitable for modeling complex systems, including simulating natural and social phenomena. I chose ABM because ABM has become an easier model to understand as the object represent individual things in the world and make it possible to explore the connection between the micro level behavior of individuals and also their interaction. So maybe it will be the best after adding some improvements on its specification, like the type of the person, maybe is he or she comorbid or not, or maybe specification on each area. Is it answered, Raka?
Yes, thank you, Sophie.
Okay, we have time for one quick question. I guess there was Nabila Asifa, if I'm not mistaken, raised her hand. Or who was it?
I did, sir, but actually my question really similar to Raka, so I guess I didn't have to ask.
Okay, thank you. Okay, so for time efficiency, we would like to thank Nabila Safri for giving us a tremendous talk in related to COVID-19. And we're going to move on to our last presenter of today's session, which is Muhammad Rido. Has Rido joined the class?
Yes, sir.
Okay.
I already joined.
Okay. All right. Okay. The time is yours.
I will start my video. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ridwanul Ihsan, and I will present about identification of geothermal potential using long offset electrical assistive tomography method in Keflavik, Iceland. Iceland has a huge geothermal potential based on the location of the country in the mid-Atlantic oceanic ridge. The geothermal resources in Iceland are used to for a great extent are used for both electricity generation and direct use. In the high temperature field, the geothermal steam is used for electricity generation, and the low temperature field is used for to supply hot water for heating for the house. And the picture on the right is the installed capacity geothermal power plant in the world. Usually, the geothermal exploration is carried out using the MT method. However, MT method sometimes it is cost a lot of money. But to reduce the cost the geothermal exploration, we must use other methods. This method, that is long offset assistive tomography, can be used for the alternative method for geothermal exploration. The purpose of the research is determine the usefulness of long offset assistive tomography measurements in the volcanic environment for geothermal exploration, and identification of the lithology and mineral composition at the investigated site for validating ERT interpretation. This is the survey area from that research. The Keflavik high temperature geothermal field has about 40 production boreholes, several exploration boreholes, including this KS01, KH01, and KH03 have also been drilled. For the measurement, we use a total of 1.2 kilometers long profile will be shoot with ERT and VIP. Yeah. And the additional long ERT profile that is indicated by long was measured in the continuation of ISL line profile all the way to KS1 site. For validating or for confirmation of the exposition, we must consider the borehole observation data result. In the borehole KS1, temperature below 4 degrees Celsius is observed in the first 300 meters, but reach 300 degrees Celsius at 2,500 depth. Yeah. In KH3, the temperature is about 10 degrees Celsius in the first 250 meters. On the other hand, a strong temperature gradient is observed in KH1 with the temperature reaching 175 degrees Celsius at 200 meter depth. This is the main equation that used in the electrical assistive tomography. Yeah. This method consists of injecting a direct current or DC along the profile to ground electrode. The profile is shown on the next slide, and measuring the resulting voltage at two other electrodes. The apparent resistivity is determined by this equation, where IAB is the current injected between electrodes A and B, Vm, and the Vn is the potential measured at electrodes M and N respectively. And K is the geometric factor. It's determined by this equation. This figure is the setup for the measurement. For the configuration that we use is the Werner configuration. For the data acquisition, choose 1 point to 24 kilometer long parallel cable with 50 centimeter long steel electrodes grounded every 40 meters were connected to an Abm terameter LS instrument. One cable for current injection and another for voltage measurement. For the data acquisition, we use the instrument. This is a sample of data processing and inversion. This is a note from the from the data that we get. This is the result of the inversion. First, this is for the long profile. Yeah, long profile. You can see this. You can see the path in this picture. The investigated area is characterized by caldera boundary, the geothermal alteration, large groundwater flow, and it is affected by both basaltic and rhyolitic fissure eruption as well as volcano tectonic lifting episodes. These features result in large resistivity contrast with the resistivity as low as few meter with where active geothermal circulation take place. The lower apparent resistivity is indicated by blue color. Next is the inversion result for KH1 site. The inverted resistivity models from the profile, yeah, ISL10, ISL11, and ISL12 like a center low resistivity body from the surface to the depth of investigation or DOI with a resistivity in the range 5 to 10 or meter over the whole body. In comparison, the surrounding agent is very resistive, up to 10,000 or meter at the surface. The resistivity values obtain the inversion of this profile are consistent with the electrical loads in borehole KH1, located at 17 and 84 meters from the center of this profile, respectively. This is a comparison between data is from the well logging and the inversion result, and also the data collection with this done in the laboratory. We observe that the lighter logical resistivity at room temperature, that is about 25 degrees Celsius, has an average resistivity about 1 order of the magnitude higher than in situ borehole observation, which is 3 to 6 ohmmeter, and inversion result, which is 5 to 10 ohmmeter. After the correction from the effect of the temperature using coefficient 0.09 1 per degree Celsius, the resistivity, the lighter-logical resistivity log overlap in situ borehole observation. The equation for the temperature effect on the resistivity is determined by this equation, where T is in situ temperatures and T0 is room temperatures, which is in degrees Celsius, and alpha O prime is the correction coefficient, and O prime is resistivity. This is a 5 lighter logical layer in the borehole and in the electrical resistivity. Average values and standard deviation within each group are given based on the laboratory resistivity of 3 to 6 sample that measured on room temperature. Next is conclusion. The first conclusion is long offset ERT method can be used for identification for geothermal potential agent that is consistent with a laboratory frequency domain measurement on the borehole sample from that site. And long offset ERT methods is useful to detect and discriminate the lighterology in the site, although have limitation to identify certain mineral. I think that's all my presentation. If you have questions, you can ask me. Thank you.
Okay, thank you. Question from the audience for Rido. Do we have question for Rido? Okay, in this long offset ERT, it is mentioned that the configuration is a Wenner configuration, if I'm not mistaken.
Yes, it's the Wenner configuration.
Okay, so do the authors say any consideration why they choose Wenner? Because most of the long offset ERT usually done with dipole configuration. Do they tell us any reasoning why they choose Wenner?
Unfortunately, in the literature that I use for this presentation is not stated clearly why the research use the Wenner configuration.
yeah, because but do you knew that other researcher when they use long offset ERT, they use typically a dipole or pole dipole. Do you knew about it?
I know a little about it.
Okay, because there was a presentation given by Pak Bagus Andar not so long ago, where he okay, so you do so you also present on the Pak Bagus talk. I think it was the last one. He used dipole, which is basically typical for a long offset because it is considered that dipole will have deeper penetration. Okay, because long offset, the objective of long offset is to get deeper penetration in with the loss of a certain accuracy or in the number, because obviously when there is the have better quality in terms of the accuracy, but it lacks when we did some kind of enlargement to the current probe. It will have a decreased energy or current energy that is injected into the ground. And so in this study, they discovered the heat source. Could they locate the heat source itself, or they just detect the reservoir?
In this study, they actually they just use this method to compare with induced polarization and from the assistivity, and they only get the reservoir.
Okay. So even though it is long offset, but it doesn't necessarily mean that you will get the generating heat source in Iceland. Even though Iceland itself is a volcanic area where the magma is relatively closer to the surface compared to Indonesia, right? So because their volcano is always active all the time. So even though they are using long offset, it is still not able to penetrate into the heat source. But unfortunately, they already get the reservoir that they need. Okay. Do we have questions from the audience for Rido? Okay, if there are no questions, then we will conclude our session. Thank you for all the presenters today, to Nabilas, and then Rido, and then Anita, and then Fadila, if I'm not mistaken. Fadila, not Fadila, but let me see. Scientific communication. I'm sorry. Okay. So we have Nabila Nermina, Anggita, Bauya, Rido, and also Nabila Safri, who already present their selected topic. Thank you all for your attention. We're going to meet again on Tuesday for the third session of students' final presentation. Okay, I will stop the recording.